Hello guys, my name is Luís Rita. I'm co-founder at Cycleai and a PhD student in Imperial College of London. The goal of our startup is to empower bicycle riders to fight for their own safety through AI. The way that we are doing this is by running in our website two crowdsourced models. One that we ask users to point in a map places they have passed by they consider of higher risk, and the second one we show users two images and we ask which one looks safer. We are going to use the first to validate a tool that we created, that is able to extract a safety score from an image in a cycling perspective and the data from the second crowdsource to train the same model. We are a team of 5, along with Miguel, the second co-founder. We have Codrin, Gonçalo and Francisco. Miguel is going to present you some of our goals next, along with our market approach. Codrin is going to present you in detail our two crowdsources. Gonçalo is going to present you the tool that I told you about, the one that's able to extract the safety score from an image, and Francisco, all the data analysis. Finally, I will close this presentation with the most practical applications of the products that we are developing.
Hey everyone, my name is Miguel and I'm a co-founder of Cycleai. As my other co-founder, Luís, already stated, we're now a team of 5 members. But before this reached this point, there was nothing. It all kind of started in May 2020 when I was hit and run by a car at a bike path near my hometown in Portugal. At this point, I felt that something must change. Back then, micromobility users were already feeling unsafe in the streets. In Portugal, in fact, road accidents and road risk factors are not really taken into account. Therefore, I acknowledged Luís's work as he was distinguished with the prize of top 25 under 25 in the digital section. Then I realized that he was performing his Masters of Research at the Imperial College London, studying the risk factors for bicycle riders. Back then, in November, we started Cycleai. Our motto was to empower bicycle users for their own safety. Back then, we had a big and really marked social impact, charisma, that we wanted to take advantage of. We had a reason for this. We had a motive and we had the solution. We then joined forces with our first colleague, Codrin Bostan, who will be talking next to me. And he is responsible for the software development of Cycleai. Together with him, we've developed our first tools and our first models of the technology being implemented, and we first reached our first conclusions. From then, we're starting to take a different approach into Cycleai, moving from the B2G side also to the B2B and B2B2C sides of the game. We're now trying to empower bicycle riders and micromobility users in all verticals, B2B, B2C, and B2G. Cycleai acts as a social impact company that is willing to improve safety for micromobility users and then to foment the usage of bicycles and other micromobility vehicles. We're now reaching a point where we are developing our first prototype with a Portuguese municipality, which is undisclosed yet, but we are about to study the city through our artificial intelligence tool, and then we will give an output of the road risks and the road safety of micromobility users in a specific city. From that point, we are willing to take over the whole world. All we need is Google Street View. The will, we already have it. The team is with us already. So now Codrin will tell you more about our solutions.
Hello, my name is Codrin Bostan and I'm a student at Imperial College London and a web developer for Cycleai. Being a cyclist myself has made me realize how dangerous the road can be, and this is part of the reason why I choose to join the team, to do something about it. More precisely, we have developed an interactive map where the users can pinpoint a place that they consider to be unsafe. Afterwards, anybody can access the description of it alongside with a picture, and if they feel the same, they can upvote that place. Also, this will help the municipalities to better concentrate their resources in more specific places. Furthermore, this is our validation mechanism for the tool that we are aiming to build. Our second crowdsource will help us understand and quantify the perception of safety, because this is a very subjective metric. We show the users random pairs from 10,000 images and ask them which one they consider to be the safest. Afterwards, by using a ranking algorithm, we can rank them from the safest to the most dangerous. And not only that, but we can understand how a presence of a specific object influences the perception of safety. More about this will be presented by my teammate Gonçalo. Thank you.
Hello, my name is Gonçalo Moreno and I'm a machine learning engineer at Cycleai. My expertise involves machine learning, of course, but more specifically computer vision, which is something that is used a lot in Cycleai. So my main job is to work on the machine learning pipeline in Cycleai. So starting from the images to the processing that the images get, all the way to our model outputting a safety score, which is then used for a cyclist to know whether or not he's in a safe environment, or to even do routing of a path that he needs to take. So, starting with our pipeline, the important model that we use, a really important model that we use is, of course, YOLOv5. It's a readily available model from GitHub, and it works really well. It's really efficient. It has really good accuracy, and it's really fast. It can even run on low-power devices. You can see that it gets an image, and it draws bounding boxes on the different types of objects, and also how confident it is that object. You can see the examples on the images in this slide. Then, after the objects are detected, we then pass it to another model from NVIDIA. This time it does image segmentation. So it's a very complex model, and what it does, it paints the different images with what kinds of object it is. So we can see that it painted purple the road, cars are painted blue, and the trees are painted green, and walls with this kind of whitish color. The output of this model is going to be an histogram of the pixels. It's going to say, for example, that the road is 20% of the image. It's going to say that the cars are 10% of the image, and that the trees are, say, 5% of the image. This, of course, is fed to these two outputs from YOLO and the image segmentation are fed into our model, which is a deep neural network, similar in style to what is on the lower left of this slide, of course, much more complex. It is based on ResNet, which is kind of a complex, state-of-the-art architecture, and our model is kind of complex. It requires a lot of training. So it gets the outputs from the images from YOLO and NVIDIA, and then combines them, and it outputs a safety score. And we use AWS to train our model, and we can see here an image of our model training. Of course, this is very early on. It only went through not even 0.1% of the total epochs, and the final accuracy that it gets is about 70%. And the output of that model is, of course, a safety score from 0 to 10, or 0 being the lowest safety score and 10 being the safest. Of course, this is not the entire machine learning pipeline. We, of course, tend to do some pre-processing of the images, and we also need to balance out the data set. But now my colleague is going to talk about other parts of our project. His name is Francisco.
So, analyzing the hotspot map data, we can see that we have almost reached our goal of having 100 identified unsafe cycling locations across Europe. 441 votes on the hotspot locations have been registered, meaning the community is engaging well with the crowdsourcing tools we have available at our website. Further evidence of this is seen through the perception poll analysis. We have registered 4,449 different poll voters and almost 50,000 votes on the perception poll images. These are very good numbers, which show that people care about cycling safety and leave us very optimistic about the future. We have also analyzed the outputs of the detection models and the segmentation model as well. Here we can see two charts where the first one on the left is relative to the detection model, and we have the number of detected objects for each class. These are just the most present classes, and we can see the class car is very present among all images, as expected, because we have a lot of road images. So on the right we have the segmentation classes and the number of detected pixels of each one. Here we have classes such as sky, road, building, vegetation has the most present classes. We decided to work on a way to find some correlation between the safety measures we had and the detected and segmented classes from the models. In the case of the detection model, we compare the average presence of detected objects from each class in the safest and most dangerous images and compare it to the average across all images. These are some of the results we found. So from here we can take that safe cycling paths are usually in the presence of people and other bicycles, where buses and trucks are clearly present in dangerous situations or locations. The same was done for the segmented classes. We can see, for example, sidewalk and bike lanes are seen in the safest images, and these are very important results since we believe that Cycleai is the first to quantify the notion of safety with objects and segmented classes for cycling safety purposes.
We don't have to limit ourselves to execute only one image with Bikeable. We can execute thousands or millions and build safety maps for entire cities in milliseconds. As an example, our first safety map that we aim to build is for Lisbon. By considering 250,000 points, 1 million images, we'll be able to build a safety map with 20 meters resolution. This will allow us to build a route planner that not only takes into account the time, the distance of traveling, as well as the safety for the first time, in an analytical and clear way. Although images are static and they don't allow us to take into account factors that are dynamic, such as the ones that are most often involved with accidents with bikes, which are pedestrians and cars. This is why we aim to integrate cameras in these vehicles, bicycles and scooters, and by scanning the surroundings 360 degrees in real time, we'll be able to alert the user about the threats and trigger some type of actions in these same vehicles. We have been having some visibility lately. We won the hackathon organized by the European Cyclist Federation. We got the computational power that we needed to go ahead with our project. The implementation in the metropolitan area of Lisbon was given to us after winning a challenge organized by them, and most recently we obtained the validation of how important our electric mobility solution is by Microsoft and Galp in the last challenge that we won, Building the Future. This is our timeline. We are founded in October, our crowdsources were launched in January, Bikeable is available since April, we are being incubated in Startup Lisbon, pre-accelerated by EIT, and we have participated a few days ago in a congress organized in Barcelos. Now we have the great pleasure of being in this event, and in September I hope to see you all there in Velocity this year, organized in Lisbon. Thank you very much all, and hope you enjoy our presentation.